Everyone, I welcome you to the second episode of Mathematics for SS2 course. And in this episode will signify the beginning of SS2 work. And hopefully, as you join me in this first episode, you are going to join me to the end of this course. So hopefully, this course is a very interesting one. So just try as much as possible to gain from every episode, because even though you might think you will understand every part of it, so there are still parts of mathematics which are a little bit unwieldy, and I might introduce you to some new things and new methods. So take some little time out to watch this episode and this course. Now let's talk about natural processes. So, and these natural logarithms, they involve the logarithm of numbers to the base of 10. Now this natural logarithms is what we'll be dealing with in mathematics. There are other also types of logarithms we'll deal with. We also have common logarithms. So we'll deal with common logarithms in mathematics too, and that is what we're dealing with in this video. Now in this video we'll be making use of the logarithm table, and I won't physically be using it in this video, but in the former episode, the first few episodes of the SS1 course, I talked about logarithm, and I also introduced you to the logarithm table. So you can also check that video out if you don't know how to use your logarithm table. But this video I'm going to be delving into the main part of the logarithm, and we'll also revise through what we covered in the previous videos. Now in the previous videos concerning logarithm, we talked about the logarithm of numbers greater than 1, logarithm of numbers, multiplication and division of logarithms, logarithm of power of numbers, and so on and so forth. So we'll also be doing all that as revision here, and in addition we are going to be moving further to logarithm of numbers lower than 1 and powers of numbers lower than 1, and other things you also want to know. Now first of all, let's talk about a revision class. Let's do a revision. So now logarithm always stems off from standard form. So let's look for the standard form of 0.031. Now when you are expressing a number in standard form, I should have understood this, but this is just a revision. Now all you need to do is you are going to move the decimal number, the decimal place value, to the number of places till you get to a non-zero number. So here we are going to move it to number of places, that's 1, 2. Now we've gotten to a non-zero number, so we are going to stop there, and then you record your answer, 3.1, then times 10 raised to the power of times you moved. So you moved twice, right? That's 10 to the power of 2, but this time around, because you moved 2 times to the right, you are going to record it as a negative number. So 10 raised to the power of minus 2. So this will be 0.031 is equals to 3.1 times 10 raised to the power minus 2. Now that's simply how standard form works. So you can also try on your own. Can you try to look for the can you try to express 500.8 in standard form? So if you pause this video and try it, so your answer should be 5.008 times 10 raised to the power 2. So this time around is positive because you are moving to the left as standard form. So let's go on to in logarithms. We also make use of the multiplication and division. So how do you look for the logarithm of multiplication and division processes? So before that, let's talk about what a logarithm is based off. So we have the logarithm of a number is expressed in 2 parts. The logarithm of a number is divided into the characteristics, which is the whole part of a logarithm. Then the mantissa is the decimal part. So if you have 2.631, your characteristics will be 2, and then your decimal part will be your mantissa, which is 6.631. So this is characteristics part of 2 and 631 as your mantissa. Then your characteristics part is determined by, and also determines the let's call it the number of the power which you raising your 10 to. So this time around you are looking for the logarithm of number 0.6. So you are looking for the antilog of 0.631, and then you multiply by 10 to the power of 2. So that's what the characteristic is. It determines the characteristics of the number, while the mantissa is the original logarithm. So let me demonstrate that. Let's look for the logarithm of 76.7 times 308.2. So this time around we are going to be dealing with multiplication. So what you do is 76.7 times 308.2. So you can decide to just do it directly, or you can just you can make use of a logarithm table. Let's do it directly in this case. Now this when you are multiplying numbers, it's still the same thing as adding their logarithms. So what's the logarithm of 76.7? That is 1.8848. Now what is the logarithm of 308.2? That will be 2. 0.4889. So in this case, you are going to add their logarithm because it is a multiplication. So, but if it's a division, we are going to subtract their logarithms. So let's add their logarithms. So when you add everything together, you will get an answer of 4.3737. So that will be the answer. So when you look for the antilog of this number, you will get the value of this multiplication in normal numbers. So I want to give that to you as an exercise. Can you look for the value of 4.3737, the antilog? So when you look for the antilog of 4.3737, you will get the value of in logarithm back as your original question or as your result. So when you multiply these numbers, this will be the answer in logarithm. You evaluate in logarithm, and then you look for your answer in logarithm, and then lastly you convert your answer in logarithm back to your numbers using antilog tables. That's simply how it works. So what are we if we are looking for the powers of numbers, powers and roots? So powers and roots are still the same thing because roots are basically reciprocal powers. So for example, let's look for the logarithm let's look for what's the value of the fifth root of 40,000. This is simply denoted as this. This fifth root of 40,000 is simply 40,000 raised to the power of 1 over 5. So that's another way of representing this. So probably this will be an easier way for us to work the logarithm. So what you need to do is just look for the logarithm of 40,000, and so that will be 4.6021. Then you divide that logarithm by 5. So divided by 5. You will get your answer in as normal. So that will be 0.9204. So that is how to look for the logarithm of a numbers, and using a logarithm to evaluate the powers and roots. So these roots are simply powers, but reciprocal powers. So that's just how you should understand it. So there's no difference between powers and roots. So if this was 5, we'll be multiplying by 5, but since this is 1 over 5, we multiply by 1 over 5, or in other words, we divide by 5. So that's how to work. So that's the revision of what we've been doing so far. So let's go on formally to logarithm of numbers less than 1. So anytime you have numbers that are less than 1, they always have a negative logarithm. For example, the logarithm of 0.037 is minus 2.5682. So because whenever you express 0.037, now like this, sorry, 0.031, when we express it in standard form, you can see that it is 3.1 times 10 to the power minus 2. So this minus 2 here will be the characteristics. That's so the logarithm will be the logarithm of this answer of this number will be minus 2. So that minus 2 you put it above on top points. Then you look for the logarithm of 3.1. That's point that will be 0.582. That's 0.582. 0.5682. That's minus 2.5682. So that's how it works. That's how to look for the logarithm of negative numbers. So of numbers less than 1. The logarithm of numbers less than 1 will always be negative. That's how it works. So let me give an example. For example, what if we were to multiply numbers with negative logarithm? So let's give this question of 0.7685 multiplied by 0.03415. Now in this example here, what we are just going to be doing is we are just going to be expressing these numbers in standard form. So 0.7685 will be what? 7.685 times 10 to the power minus 1. Let's enclose it in brackets to distinguish it as a number on its own. Then multiply it by 0.03415. That will be what? 3.415 times 10 to the power what? Minus 2. So simply what you'll be doing is that in order to avoid stress, so all you need to do is this minus 1, the power of 10 will be the characteristics of your logarithm. So you've gotten one part of your answer already. That's minus 1. You put the minus above the 1. So that as it will be expressed as a bar above. So that's bar 1. That's this one. I hope you can see it clearly. The end point. Then you look for the logarithm of 7.685. That would be 0.8857. So just minus 1.8857. So this multiplication symbol will change to plus. You are adding, because anytime you multiply numbers, it's the same thing as adding their logarithms. So this one has the characteristics of -2, which is the power of 10. So plus minus bar 2, that's -2 point. What's the logarithm of 3.415? You will get it on your table as 0.5334. That's -2.5334. So this time around, when time you're adding the characteristics to this matrix, you don't add them. When time you have a negative value for logarithm of values less than 1, you don't just add the characteristics and the matrix. The characteristics will be separate from the matrix. So this is -2 plus 0.5534. You can't say -2 plus 0.5534. So it will be separate. That will be -2.0.5534. That will be -2.5534. When you add everything, you add the characteristics on their own and add the matrix on their own. But this time around, when the matrix is up to 1, you can move that value to the characteristics and add it. But you cannot you cannot subtract or add the characteristics to the matrix. But you can add the matrix to the characteristics. That's just how it works. So this time, this -1 plus -2 is -3. You add the characteristics first. Then when we add the matrix, we'll get a total value of -3. We get a total value of when we add everything together, we'll get 1.1625. When we add 0.8857 plus 0.5534, that's 1. Yeah, that would be, yes, that's 1.625. So in essence, our answer will be -2. That's the 2 is placed above. -2 point our total answer will be 0.024. So when that's the equivalent of all this. When you add the logarithm, I think you can also try that. You add the matrix, then add the decimal part. What you get as your answer, you combine them together, and then you look for the antilog. That will be 0.024 as a final answer. So moving on, let's see what we can do about the powers of numbers numbers less than 1. When we want to look for the powers, so how do we calculate that? But before that, let's talk about whenever you are subtracting and adding, how to subtract and add. For example, this kind of question I gave, so it looks as if we had a little bit of a hitch in that point, right? Let's try it. So I won't skip it. I'm going to try it in this video so that you know how to do it. So in this question, we have -1.8857. That's you put it as a bar above, -1.8857. Then it is added to -2.555334, -2.5334. So what you do now is you are going to keep adding, start adding just like a normal way. 7 plus 4 is 11. Write a 1, keep 1. 5 plus 3 is 8. Add the 1. That's 9. 8 plus 3 is 11. Write 1, keep 1. 8 plus 5 is 13. Write 1. 13 plus 1, that's 14. 14. Write 4, keep 1. Now -1 plus -2 is -3. Then you add the one that you've kept over. So this one that has been transferred over, that will be -3 plus 1. That's -2. So your final answer will be -2.4191. So this answer, our answer is -2.4191. So what you do is, when you want to convert back to your initial answer, you just look for the antilog of 0.4191 on the antilog table. Then you are going to multiply your answer by 10 to the power of -2. So this characteristic will determine your answer when you convert back. So that's why we have 0.024 as our answer. So let me give another example. This time around, let me deal with subtraction. What if we're subtracting minus 5.7 minus 2.3? So what if we're doing something like this? So how would we go about it? So this is simply how you do it. Another way of doing this kind of work is by separating your logarithm. So this will be -5 plus 0.7, and this second one will be -2.3 is -2 plus 0.3. So we're subtracting the second from the first. So what you do is you just subtract the matrix separate, and subtract the characteristics. So 0.7 minus 0.3 is what? 0.4. That would be answer on the matrix. So the characteristic is -5 minus -2. That was -5 plus 2. That's -3. Because minus plus minus times minus is plus. So -3 plus 0.4 is what? -3.4. So this time around, you want, if you are doing in normal arithmetic, that -3 plus 0.4 is -2.6, right? But this time around in logarithm, -3.0.4, and when the minus is above like this, -3.0.4 is -3.4. So always take note of that. That is the only difference I'm trying to explain in this this is simple addition and subtraction. But what makes this stand out from your normal arithmetic is that in this case you don't just add your characteristics to your matrix directly. So now, having gone to this extent, let's get to the end of this series by finally talking about let me give a complex question. So this time around, this question is a little bit complex, and then I would like you to pay full attention to this, to how I'll solve it. So we are looking for the fifth root of the division of 6.2391 by 242.7. So this time around I'm going to make it of a table. So in previous examples I have not made use of a table. This is the question. We are looking for the fifth root of 6.231 divided by 242.7. So we just set up a table of the numbers. The numbers is what? Numbers and their corresponding logarithm. So the first numbers, we have 6.231. So we are going to look for the logarithm of 6.231, and then we are going to look for the logarithm of 242.7. So 6.231 has a logarithm of 0.7946. So next we have the next number is 242.7. So if we express 242.7, that will be 2.42, 2.427 times 10 raised to the power what? -2. That means this power of 10 minus 2 will be our characteristics. That's -2 points. So then our matrix will be divided by will be determined by the logarithm of this value. That's the matrix is determined as the logarithm of 2427 is what? Logarithm of 427 is 3850. That's -2.3850. So we just look for the logarithm of this one and adjust the decimal points according to the characteristics. So now we've gotten the logarithm of these two numbers. So the next part of it to do is, now we are going to look for the logarithm process. So logarithm simplification. So when we are dividing numbers, we are going to subtract their logarithm. So that was 0.7946 minus 2.3850. So we'll simply do it like this. When we subtract, that would be 6 minus 0 is 6, 4 minus 5 is impossible, let's borrow 1, give 8. 14 minus 5 is what? That would be 9. Yeah. 8 minus 8 is 0. Now 7 minus 3 is 4. Now 0 minus -2 is what? 0 plus 2, that's plus 2. So that would be how it will work. Yeah. So that would be -2, that would be -2 instead, not plus 2. That will be -2.4096 in this case. So having done that, now the next part of it is because this time around the logarithm of this one is actually plus, is a plus 2, 10 to the power 2, so it's a positive 2. So that will be 0 minus 2, that's -2, -2. So now we've gotten the answer here. Now the next part of this is we are looking for the fifth root of this result. So when you are looking for the fifth root of a number, it simply implies you are dividing the logarithm by 5. So if you are looking for the power of if you are looking for the logarithm of a number with power, you simply multiply the logarithm by that power. So the logarithm of 2 raised to the power 2 will be the logarithm of 2 times 2. So now the logarithm of this number raised to the power 1/5, or to the fifth root, is the logarithm divided by 5. Now this leads me to another last part of this video. Let me explain how to divide logarithms. So now when you want to do something like this, this is -2.4096 divided by 5. Now you are going to separate this into two proportions in such a way that both the characteristics and the matrix will be divisible by the dividend. So now this dividend of 5, we are going to say, okay, now let's make this 2 2 cannot be divided directly by 5, so let's make this 5. So if we change it to -5, so what would we add to the matrix that would make this change back to 2? So that we'll have to add 3. So when we subtract 3 from the characteristics, we are going to add 3 to the matrix. That's -5 plus 3.4096, and then everything divided by 5. So when we divide both by 5, -5 divided by 5 is -1 point. Then 3.4096 divided by 5, that would give us 6897, 68119. Sorry. So this will be our result. So because this is how to divide a number, a negative logarithm, by another number. So now when we look for the antilog of this one, we will get our answer as 0.025, 0.4807, 0.4807. That will be the answer of this question. So thank you for watching, and see you next episode.